Get ready to rumble! Y'all ready for this?
Okay, so that was an introduction. I'm not sure how that went or how the audio was, but well, that was an introduction. So let's get started. Hopefully, by doing this, you're going to be able to, well, do well on the retakes. I'm going to be doing the version A and version B, and also some side questions as well. Give me a second. Okay, so hopefully the audio is going to be good, but hello everybody. So like I said, I want to be doing version A for chapter 9 test and also version B for the chapter 9 test. I'm going to be doing some side questions as well of each type of problems, do some variations so you could see what the differences are. But hopefully, you'll be able to do it. Okay, let's get started. I hope the audio is going to be good because this is just going to be one take. I'm not doing any do-overs. If I need to go to the bathroom, I'll say something like bathroom break, and I'll put a little note on the screen saying a bathroom break, and then I'll be back. Just one take. No do-overs. Okay, let's get started. Okay, chapter 9, version A. Now, whenever you deal with the absolute values, you always want the absolute value to be by itself. The only way that you can actually split it up is if the absolute value is by itself. So, your question is this question, is the absolute value by itself? Well, yes it is. You only have the absolute value on one side. So that means it's by itself. There's nothing on the side. There's nothing in front of it, just by itself. Once it's by itself, split it up. You got two versions whenever you have the absolute value, a positive and a negative side. The positive side, nothing changes. For the negative side, this does change slightly. So you see how you got a positive 3 on the left side for the positive side? You are going to be getting a negative 3 on the right side. But not only that, your actual inequality symbol is going to be switched. So you see the inequality right here? Look at this inequality right here. They switch sides. Whenever you do the negative side, the inequality must switch. The reason why is because whenever you multiply or divide by a negative number, when you're dealing with inequalities, the inequality symbol switches directions. So for example, if you're facing this direction and say that you divide by -2 on both sides, the sign flips. So it's no longer this direction. It is going to be this direction. If you multiply by a negative number, same idea. You're going to be switching the actual inequality symbol. Now, hopefully everyone is so far no questions. You can always replay the actual video. Okay. Now, I need to just treat it like an actual equation. Just pretend that you need to get x by itself. So in order to get x by itself, well, I need to get rid of this positive 1. The opposite of adding 1 is subtracting 1. Subtract 1 on both sides. We got negative 5x less than 2. Now, in order to get the x by itself, I need to do the opposite of multiplying by negative 5. There is a multiplication. When you say negative 5x, you're really saying negative 5 times x. So the opposite of multiplying by negative 5x, or negative 5, is dividing by negative 5. Divide by negative 5. Your answer for the left side, the positive side for the absolute value, is going to be x and negative 2/5. But what happens to the inequality? Again, whenever you multiply or divide by a negative number, when you're dealing with inequalities, you're going to be switching sides, switching the direction of the inequality. Notice how we have the inequality facing this direction to the right. It's opening to the right, but now it is opening to the left. Okay, same operations. You're going to see something very interesting. The same operations are going to be happening for the right side as for the left side. Now, same idea. You need to get x by itself. The opposite of adding 1, subtracting 1. Subtract 1 on both sides. We got negative 5x is greater than negative 4. Okay. Now, same operation. The opposite of multiplying by negative 5 is dividing by negative 5. We'll have x and 4/5 on this side. Now, negative 4 divided by negative 5 is going to be positive. A negative divided by a negative turns into a positive. Now, again, the same reasoning. Look what happened that we did. We divided by a negative number, so that means the inequality must switch directions. Notice it is the exact same operations. The only difference is the end result. The numbers are slightly different. This side, it is a negative 3. This side is a positive 3. But the same operations still happened. You still had to, the first step that we actually had to do was subtract 1 on both sides. Subtract 1 on both sides. The next step was divide by negative 5. Divide by negative 5. Same exact operations, same procedure. When I divide by a negative number, it switches the direction of the inequality. When I divide it by a negative number, it switches the inequality as well. Same exact direction. Now, when you do trying to graph this inequality, I do not care that it doesn't have to be perfectly to scale. I'm letting you right now. Pick whatever actual points. You can just assume that it is to scale. I'm not going to be picky about it. Hopefully your future teachers will not be also picky about it, but I'm just going to leave it as negative 2/5 here, and I'm just going to say this point over here is positive 4/5. I'm just going to assume that these are the actual, and everything's perfectly to scale. It doesn't have to be perfectly to scale. You don't need to justify it. You do not need to give your number right here, or right here. You can just leave it alone. Just pick two sides. You just assume that it is going to be perfectly scaled. Nothing to worry about. Now, you have to figure out which direction are you going to be doing. But before that, you need to see if this is going to be an open circle or a closed circle. Now, I'm going to write down some notes on this side. Maybe I should do it on this blank sheet. When you have an inequality, these ones, they are going to be an open circle. There is no line underneath, just an open circle. Now, when you have a line underneath, that means it's going to be a closed circle. It's going to be included. I want to add to this chart later on. You're going to see what I mean in a moment later on. Okay, I'm going to leave this. We're going to expand on this part right here later on. Okay, so this is going to be an open circle for both of them. Open circle, open circle. Why? Because there is no line underneath. This is a strict inequality. So this says x has to be strictly greater than negative 2/5. This is saying x has to be strictly less than 4/5. Okay, now, since we know it's an open circle, we got to see the direction. You see how it says x is greater than? That means we are getting more than negative 2/5. Now, if you were to look at the number line, negatives go to the left, this direction. Positives go this direction. So when I say x is greater than, that means you're saying it is more than negative 2/5. That is going to go in a direction to the right. So that's going to be like this direction. Now, the right one, this inequality, this is going to say x is less than 4/5. That means you're going to go down. So that means this direction. When you have two inequalities facing each other, the solution for this inequality will be between negative 2/5 and 4/5. Now, you can combine this inequality. I was not testing you on the actual combination or combining the inequalities. You're probably going to be doing that in IM2 and IM3, depending on your actual teacher. But if you really want to actually have the inequality in one nice form, some of you have been actually writing it down, this is what it will look like. If you really want to actually have it in one single inequality, one nice inequality, this is your answer. But if you did it separately, that is fine. You can have either one. But if you want to be more precise, it is going to be this way. I was not marking students down if you had it this way or you didn't have it this way, where you just had it split up. It was perfectly fine. As long as you're showing that the actual solution was in between. Only the answers in between negative 2/5 and 4/5. That's going to be the solution. That is for A. Hopefully there's no question. Now, for this one, again, you got to ask yourself, this is for absolute values inequalities. I need to ask myself, do I have the inequality by itself? This is your inequality. Is it by itself on the left side? No, it's not. It is surrounded by that, or you got a negative 8 right here. That negative 8 is on the left side. We do not want that negative 8 to be on the left side. We just want the absolute value by itself before we can split it. A common mistake that I see on the test is students do the actual split before the actual absolute value is by itself. You need the absolute value by itself before you can do the split. So in this case, you would need to add 8 to both sides. Add 8 to both sides. You are going to get 9 on the right side, and then this inequality on the left side. No change whatsoever. Let me move this a little bit so it makes it a little bit nicer. There you go. Okay. Now, once the inequality is by itself, which this is by itself, you only have the inequality on one side. Then that's when you are able to split it up into two sections. A positive side and a negative side. I talked about why we actually had to split it up, a positive and a negative side, in class. If you would like to actually discuss that, I can show you examples in person so you understand. But right now we're just practicing on doing the actual problems. Now the left side, let me actually erase a little bit so I can save some space. So the left side is going to be negative 4 1/4 x plus 6 greater than 9. I gotta write a little bit smaller. And on the right side, it's going to be negative 1/4 x plus 6 is going to be less than or equal to negative 9. Whenever you do the negative side, you need to make sure that you flip the inequality. This inequality flips into the other direction. It has to flip the other direction because essentially what you're doing is multiplying that right side by a -1 because you're giving the option for the absolute value to be having a negative answer on the inside. That's what you're doing. So let's see. We need to, let me erase this part. Okay, now we're good. Now, first thing, we got to get x by itself. We have that +6. Same operations just like the previous problem. -6 on both sides. We are going to get -1/4 x. We got 3 right there. Same operations. I'm going to do this side by side so you can see exactly the same operations. Subtracting 6 on both sides. Exactly the same. We're going to have -1/4 x on this side. And we're going to have -9 minus 9. A common mistake that I see students do is that they would add them together. It's subtraction. So this is going to be a -15. Go back to this side on this side over here. The opposite of dividing by a -4 or multiplying by a -1/4 is actually multiplying by -4 on both sides. -4 divided by -4, that turns into a 1. We got x is greater than or equal to -12. But look what happens. Is this the correct inequality symbol? No, it's not. It is this direction. It is very easy to just copy the actual answer. I wanted you to see this. Look how simple. If you did catch that right away, then good job. But if you didn't, then this is why I'm mentioning it right now. Look how easy it was. You just assume that, oh, just because you're just multiplying both sides by the same number, you're good to go. Just copy it, just go to the next number and next problem. But common mistake that I saw students is right there, right here. They write down x is greater than -12. This is incorrect. This is x is less than or equal to -12. Let's go over here. Same idea, same operations. Multiply by -4 on both sides. We will get x is greater than or equal to +60. There we go. Again, you always have to switch the inequality symbol every single time that you're multiplying or dividing by a negative number. It is super easy to just write it down. I can almost, like a lot of students, if I was just doing this normally, a lot of students would just copy this actual work and not catch the actual mistake that actually does happen once you just go quickly and try to do the problem as fast as possible. Be careful about doing this mistake. I see it all the time. So if you caught the mistake before I even mentioned it, that's good. This is the correct way. So hopefully that's being clear. We have -12 right here and 60 right there. I'm just going to assume that these are perfectly scaled. I do not care the numbers in between. You do not need to waste your time to find the actual scales. Just do -12 and 60 over here. Just assume it is perfectly scaled. Now we got to see, is this going to be a closed circle or an open circle? Well, we actually had our notes right here. When you're dealing with, so this bottom section, these two inequalities right here, these two is going to be for a closed circle. The top ones without the line underneath, without the inclusion, is going to be an open circle. If there is a line underneath, that means you are including it. So that means this is a closed circle. Closed circle. There you go. Closed circle. Now you need to find the direction that it's facing. This is saying x is less than -12. When you're saying less than, that means you are going downwards. You're going in the negative direction. That's to the left of the number line. Now over here, you have x is greater than 60. You're saying greater, so that means you're increasing in value. When you're increasing the value, you're going to the right of the number line. These are your actual answers. You can plug in actual values to just confirm that you have the actual direction. If it is correct and if it is a true statement, you can determine if it's going to be in that direction or not in that direction. Okay, next is letter C. Same goal. You want to get x by itself. There's no absolute values, so you do not need to do a split. You only do this split whenever there is absolute values. There's no absolute values right over here, so that means you do not need to do that. I saw students do this split for all of the problems, even though there was no absolute values whatsoever, especially in this problem that I saw a lot of that situation, more so than this one over here. This is the problem that I saw students split up more often than not than this one over here. But in this case, we just need to get x by itself. Let's see. I want to move this positive or this negative 1/3 x to the right side. So I want to move this side, this x to be on this side. I want to have it positive x's. I do not want to deal with negatives. Now we're going to have 1/6. We got 2/3 x minus 2. Then I'm going to be adding 2 to both sides. Now, if I were to add 2 to both sides, 2 is the same thing as saying 12 over 6. 12 over 6 is the same thing as saying 2. So let me make use of this information that I'm circling right now. 12 over 6 plus 1/6. What is 12 over 6 plus 1/6? This is going to be 13 over 6. Then we got 2/3 x. Now I need to get rid of dividing. Some students have figured out that you can do the multiply by the reciprocal. I'm just going to try to do one step at a time so there is no confusion. So multiply by the denominator. That is going to be 3. So multiply both sides by 3. I want to get that x by itself. So multiply by 3 on both sides. I will have this side to be 2x. The reason why 3 divided by 3 is 1. So not cancel, it turns into a 1. We're going to have 3 right over here divided by 6. 3 divided by 6 is 1/2. So I want to change this into 13 and a half. Next step, we want to get rid of this multiplying by 2. How do I do that? Divide by 2. Divide by 2. When you divide a fraction, you multiply both denominators. When you take a half of a half, it is really saying a fourth. What do I mean by that? Let me put a little example on the side just in case if you did not catch that. So if I were to do half and then half it again, that is really saying 1/4. What am I doing? Multiplying both denominators together in order to get my new denominator. So in this case, this will be 13 over 4 is less than x. Or you can read it the other way. X is greater than 13 over 4. You can look at it either way. It's up to you, however you want to read it. I'm just going to have it this point right here to be 13 over 4. Again, you got to ask yourself, is this going to be an open circle or a closed circle? This is going to be an open circle. Now, I got to find out which is the direction that I need to face. This is saying, if you have it on the other side, it makes a little bit more sense. I'm going to write it down. These two are exactly the same. So the things that I'm circling, they just have a different orientation, but they mean exactly the same. It might be easier to see it this way than it is this way, but this is still saying x is greater than 13 over 4. It's still the same thing, but it might be a little bit easier to see it in this direction when you flip it around. that's like the same reasoning as saying we tend to prefer to say x is equal to 4 instead of saying 4 is equal to x. It just sounds a little bit more natural to have it in this direction, but they mean exactly the same thing. Now, this is saying x is greater than 4 or 13 over 4. So that's going to go in the right, this direction. Hopefully everyone got that. You can always rewind, just to let you know. Now let's move on to the next one. Again, you want to get x by itself. Is there any absolute values? No, so we do not need to do that split whatsoever. So just only do the split whenever you deal with absolute values, and the absolute value has to be by itself. If it's not by itself, you need to do whatever you can to get it by itself and then split. Now we got to subtract 5 on both sides. We'll get 1/3 x is greater than -3. I got to multiply both sides by -3. X is going to be on the left side because -3 divided by -3 right there, or multiplied by -1/3. That's the same thing. It is going to be a 1. What is left? Just the letter x. Now on the right side, -3 times -3, that turns into a +9. Now, what happens to the inequality? Hopefully you can catch that. What do? We multiplied by a negative number. When we multiply by a negative number for inequalities, what happens to the inequality? It switches directions. So instead of facing to the right, opening to the right, it is now going to be opening to the left. Let me change that. So this is going to be opening in this direction. Now, I'm going to pick any points. I'm just going to pick, let's say over here. Just to emphasize the point, I don't care where you actually put it. You can say that this is 9. That's fine. Or you could pick, this is 9 over here. It does not matter. Or this one. Or this one. It does not matter. It doesn't have to be starting at 0 and then you count 1. It doesn't have to be to scale. Just to prove a point, just to make a difference, let's just pick this to be 9 over here. Actually, let me do this side, just to emphasize the point. I have an open circle. Reason why? It is an or I guess you could say an inclusion for an inequality. So that means it's going to be an open circle. It's strictly less than. X is strictly less than 9. So that's going to be going to the right because you are going less than 9. Anything less than 9. Go to the number line. There's a number line in the classroom. You can actually see which side is left, which is going to be just the negatives, and then the right side is going to be all the positives. So you're going to be going down because you're going less than 9 going down. That's going to be to the right. If you wanted to have it, let me just move it. If you want to have it over here, same thing. If you want to have it over here, same thing. Have it over here, same thing. It doesn't matter where you put this thing. All I care is it correct? You could put it, just assume that that's the point. Hopefully that answered this question for the absolute values and without the absolute values. And again, I'm going to be doing the same thing for version A. This is version B. This is version A. I'm going to be doing the same thing for version B. Let me see how long this is going for. This is going to be a long video. Okay, this is 29 minutes. Okay, so we just did the first problem, at least 4 problems, I guess you could say 4 parts. So this is going to be a long video. Sorry for that. If you watched it all, thank you. Okay, now we have, this section is going to be graphing, or I should say 2 variable inequalities. I believe this is the section title. It's going to be 2 variable inequalities. The reason why it's 2 variables is because you got 2 variables. You got y and x. Both x and y are your variables, and you're going to be graphing the inequalities. Most common mistake that I see was not graphing it correctly, or actually having a dotted line or a solid line, and that's pretty much it. Making sure that they're not shading. I saw more issues with this part of the actual test. I tried to give you guys warning, but some of you may have forgot. but we're going to go over it in this section. Don't worry. Now, first thing that you want to see is that this is very close to, this is a linear inequality. This is very similar to what we have been working on, is a linear function, a line. That is y is equal to mx plus b. This is almost exactly like the structure of a line, but instead of an equation, we have an inequality. Now, the same rules, the same applications is going to apply, but just slightly different for inequalities. Now, let's see. I want to graph it using purple. I think that's what I'm doing. I'm going to use blue for the slope and then B for the actual y-intercept, the starting value. So we're going to start at 2. That is your B value. This is right here. This is where your 2. Now I need to go by my slope. My slope is -4/5. Now you always remember rise over run. The change of y over the change of x. Delta y over delta x. So let's see. We have -4. That is going down 4 to the right 5. That is right here. Now the same thing. We go down 4. So 1, 2, let's track 1, 2, 3, 4 to the right 5. That's about right there. If I go up 4, where is it? 6 and then 5. That's about right here. Wait, no. Is that 4? Yeah, it's 5. Yeah, that should be a rep. Oh, that's about right. Is that 4? Wait, 1, 2, 3, 4. To the left 5. So that's going to be, okay, yeah, that's right. Okay, so far we're good. Now, we need to see if it's going to be a dot. Oh, actually, I can go a little bit one more. I can go right here. That'd be nice. Okay, there you go. That should be good. Go up 4 to the left 5. Go in the opposite direction. Now, I need to see on how you might be very tempted to just draw a straight line, because we've been working with basic linear functions this entire year, just y equals mx plus b. We were drawing lines a lot. We had an actual system of linear equations, graphing lines and how they interact, but for inequalities, it's a little bit different. You see how you have this inequality, there is no line underneath. When you have no line underneath, this is going to be an expansion of my notes right here. You are going to be using a dashed line. This is for dashed lines. When you're dealing with inequalities that do not have, or strict inequalities, that means they are not including the actual points. The actual line itself is not included. It's going to be a dashed line. It could be called a dotted line, open line. There's so many ways of being called for that dashed line. There's so many names. Now, for the line that you see underneath the inequality, that is an inclusion inequality. That's going to be included. Less than or equal to, that's going to be for the closed circle. The inclusion line, well, it's going to be a solid line. A solid line. That solid line is going to be also called a closed line. There's other names, like I said, you can choose whatever name that you prefer. I'm just going to use dashed line for that open line, the dash to make sense, or a solid line for a closed line. So this one over here, this is an open line or a dashed line. Now, I see students do this mistake. A common mistake is not having the dashed line. If you are writing it in pen, please try your best to redraw it, or better yet, do this. Just say that it is a dashed line. This way, I know without a doubt there's no confusion, because I see students do this. They tend to have a full line and they tend to erase Let's see. You see what I'm doing? Hopefully you can see it. They don't fully erase it. And I think that this is going to be a solid line. So please make sure that you're very clear. If you need to be very clear and just straightforward, just put an arrow and say that this is a dashed line. There is no confusion about that. So if you say that this is a dashed line, I'm going to say that that's a dashed line. Make sure that you are very clear about it. Otherwise, I'm just going to assume what I see. So if it looks like a solid line, I'm going to assume it's a solid line. Please make sure that you're very clear about what type of line that you actually have. Now, inequalities. When you are shading the solution for a two variable, not a system of two variable linear inequalities, it is just two variable inequalities. When you graph the solution, it is going to be a region. Now, the region is an area. So it's all the possible. There's an infinite number of possibilities. Now, there are two ways that you can actually go about this. The first way I want to show you right now is by plugging in a point and seeing if it is going to be true. So this point right here is my favorite point. I'm going to color code it blue. This point right here. This point is my favorite point that I like to use, and it's 0, 0 because you just plug in zeros. So anything times 0 is always 0. So it's super nice to plug in. Now, I'm going to plug in this point into this inequality. So how do I do that? Well, replace y with 0 because that is what the y value at the origin is. It's going to be 0. You replace x with 0 because that's what the x point value is at the origin. You're going to have negative 4/5 times 0 plus 2. Now, let's see. We're going to have 0. 0 times anything is still 0, and then you're going to have 2. Now, you got to ask yourself, does this make sense? Is 0 greater than 2? Is this true? Hopefully, you can spot that it is not true. So, this is a false statement. So it is not true. When it's not true, that means this side is not going to be the actual solution. It is a false statement. So that means anything that is on this side, which is going to be below the line, anywhere on this line right over here, is not a solution. Now, what is a solution is the other direction. Let me actually color this part right here. This direction, above it. Sorry, I need to drink some. Getting a little bit thirsty. I can feel it's hot in my room. I'm not doing any cuts, so if I make mistakes, sorry. Okay. Now, we need to see if it is true or not true. I'm just saying it is true, but let's just prove it. Let's pick a point that is above this line. Let's pick this point right here. What is this point? 0, 5. Let's plug it in. 5 for y and 0 for x. So we got negative 4/5 times 0 plus 2. I choose this point. The reason why is because I like working with zeros. Anything that I can include a 0, I will include it because it just makes things a lot easier. I do not want to deal with any numbers. I want to deal with the least amount of numbers and least amount of complication. I'm not going to be choosing a decimal. I'm not going to be choosing a complicated fraction, anything like that. I'm just going to pick really nice numbers. 0, 5 is a nice point. Sorry, not sure if you heard that. Burp. So we got 0 times negative 4/5. Negative 4/5 times 0 is going to be 0. That's just 0. So we have 2 on the right side and we got 5 on the left side still. Is 5 greater than 2? Yes, it is. So this gives a little check mark. It is going to be true. So that means this side is going to be true. Above the line, which I said previously. If it's not on one side, it has to be the other side. You can only have one side that is going to be correct. Now, what I just did, it is not perfect. I didn't fill it in. I know the actual textbook asks you to fill in fully, make it fully detailed as much as you can. So just try to make it as perfect as you can. This is like how it was on the textbook. Now, I'm not doing this. Do not waste your time. I understand when you do this little scribble that I just did right there, you can even do it less like this. This is perfectly fine. Now, what is not okay is this. That's clearly not the case. Make it very clear that you are meaning to have it on whatever side. Look what I did. If I were to go a little bit further, let me just pretend like I went a little bit further over here. You see how I went over the line like that? I'm not going to dock you points. I understand that you mean this side. It's very obvious that it is this side only. I'm not going to dock you points when you do it like this. It's perfectly fine. Again, just try your best. Just don't spend too much time wasting your time trying to shade and make it perfect. Just let me know where it's going to be the actual area that's the actual solution, and that's going to be fine for me. So this is going to be for letter A. Now for letter B, you are going to have an exponential. Now exponentials, at least for this class, is always going to be y is equal to ab to the power of x. This is a very special case of an exponential general form, but you're going to be learning a little bit more in IM3. But this is what we're going to do for this class, like what we said. Now, the best way that I can do this is set up an XY table. I always like to have 5 points. -2, -1, 0, 1, and 2. Trust me, get comfortable about using these 5 points. It will come in handy actually in semester 2 in IM2 that you are going to go in next year. Trust me, choose these nice points. It will make your job a lot easier in graphing. Do not pick complicated points. Just, make it simple. Now, let me see if I can show you on the calculator. Hold on, let me see something. Okay, this is my calculator, not sponsored by the way. Hopefully everyone gets this calculator. Parents, I really recommend this calculator. It's a very good calculator, my favorite calculator. So please make sure that you actually get this calculator. Now, what you're going to be doing is plugging in that equation. You're going to have 6 times 1. What's the problem? 1/2. 1/2 to the power of -2. Look how nice that looks. Now, on the other calculators that the school provides, it doesn't look as nice as this. Trust me, this is my favorite calculator. Not sponsored, but I really recommend that you actually get this calculator. So you press enter, and then it gives you your actual answer. It's going to be actually 24. If you put in, say, a 1, it'll give you -1. It gives you 12. Next one is going to be 0, but I claim that you already know what your 0 value is going to be 6, because that's your A value. That's your starting value. Then you plug in 1. You get a 3. If you plug in a 2, you're going to get 2/3. Now, you can leave it as 2/3, or you can leave it as a fraction. So, that 2/3, your fraction, or a decimal, perfectly fine. You can have it either one. And this is how I get the decimal, by just pressing this button. Very nice to get the actual fraction. Sometimes it is useful to actually see it. But here it is. So it's going to be 1.5. I want to say 1.5 because it's easier to use on the graph. So let me go back. So we have the first one was 24. The next one was 12. The next one was 6. Then it was 3. Then 1.5. So let's plot those points. I know it's not going to be on the graph. We can just do an estimate. Let's see. We have negative 112. I'm going to color code it to be blue. Let's say that that's negative 112. That's about right there. We got 0.6. That's about right there. Oh, hold on. I think my audio just cut off. Hold on. Let's see. This is what happens when you have to do things all... Okay. There we go. Sorry. I'm not doing any retakes, so... Sorry. This is 1.3, and then this is going to be 2, 1.5, which is about right there. Now, it doesn't show you much, but one thing is very clear. When you continue, what's really happening in this exponential? You're multiplying by 1/2. That is your multiplier. That 1/2 is your b value. The b value is your multiplier. That is what you're multiplying every single time. So if I'm constantly halving the same number over and over, just halving. So half of 3 is 1.5. Half of 1.5, it goes smaller, it goes to 0.75, goes continuously going smaller and smaller. Now, when you continuously halve something, will you ever go to 0? The answer is no. You're going to be approaching 0 slowly and slowly, but it will never touch the x-axis. A common mistake that I see students do is that they did not have these other points that I'm circling right here, and they just do this. Now, they get the curve correct, but the thing is, it doesn't cross the x-axis because you will never get below 0 or at 0. So do the best you can to just hover on that line and then just put your little arrow on both sides. This is a perfect exponential graph for this equation. Now, we got to see which side is to actually shade. But before we actually do that, is this going to be a solid line or an dashed line? Now, it's going to be a solid line. How do I know it's a solid line? Well, let's look at our little cheat sheet right over here. Whenever you have the line underneath, that means inclusion. That means it's going to be on the line. You can have it to be on the line. So let's see. This is going to be a solid line. I'm going to write down, again, solid line. Now, I need to see which side is going to be true or not true. So the best way to actually do it is just plug in a point, see what's actually happening. My favorite point, hopefully you know what it is. It is going to be the red point, which is at the origin. Now, at the orange, it's going to be 0 for y and 0 for x. Anything to the 0 power is what? Hopefully you know the answer to that. Anything to the 0 power except for 0, that's an indeterminate form. You're going to learn that later. Anything to the 0 power except for 0 is always going to be equal to 1. That is an exponent rule. So you're going to have 1 times 6, which gives us 0 is less than or equal to 6. Is this true? Is 0 less than or equal to 6? It says or equal to. It doesn't have to be equal to. Just Is 0 less than or equal to 6? Yes, it is. You get your little check mark. It is true. So that means this side gets a green light. That means I got a shade in this direction. Notice how I did the arrows on this line over here, this purple line, and this blue line. That is just to show me which direction that I'm going to be actually graphing, but this is not enough to actually show that it is going to be the solution. You need to actually shade in the part. Please make sure that you shade. This is perfectly, I know it's not fully shaded in, like this part I missed. But if you just leave it like this, I know that this section right here and this little piece right there is not filled in, but I get the whole idea is that you are shading the bottom part. It is very clear to me in this graph right here that you are shading below the line. Now, you might be wondering, is there a faster way to actually determine you are going to be shading upwards or downwards? Well, one way is by looking at the inequality. Now, you have a couple inequalities. 4 to be exact. You have less than, strictly less than, you have strictly greater than, and strictly less, or you also have less than or equal to, and you also have greater than or equal to. Now, these two, right over here, is going to be in one category. Now, whenever you see y is less than or y is less than or equal to, notice how I'm saying y is less than. That's the first thing I'm saying. Y is less than. It's okay if you have y less than or equal to. That's fine. Either one. You have y is less than. It's facing away. It's opening the inequality on the opposite direction. It's not going to. You are going to be shading downwards. Now, what do I mean by downwards? There is an upper portion and a lower portion to the graph. If I were to ask you right now, A and B, which side do you think is above the line, A or B? Hopefully you answer A. Hopefully I didn't spoil the fun, but A is going to be above the line. So that means you are going to be shading above the line. When you see y is greater than, you are going to be shading above the line. But if you see y is less than, say for example in this scenario, you are going to be shading downwards. And if I were to tell you which one is lower or below the line, it's going to be the letter B. You're shading below the line. So let me go back to my little notes over here. So if you see, you shade below when you say y is less than. If you see y is greater than, or if you see y is greater than or equal to, where do you think you're going to shade? You're going to shade above. Now, these two is for this inequalities. And then you also have these for the other inequalities. They're grouped up into sections. That's why I'm kind of building out my little notes on this side. So we're going to be using these notes. If you want to write it down on the side, you can always just pause the video and just write it on your side. And then you can continue further. So I'm going to be shading. Let me go back to shade this correctly. So this side right here is shaded up. And notice how we have less than, y is less than. And if you were to ask which side is above and which side is below, A or B, well, hopefully you could see that it is going to be below the line is B and above the line is A. So since we have y is less than, that means it is below the line. That is letter A. Or wait, letter B, sorry. Letter B is going to be below the line. Okay, let's see. This is 55 minutes. Oh man, this is going to be a long video. Okay. 3. Now, for 3, this is called system of linear inequalities. You're going to be graphing by, or solving the actual system of linear inequalities graphically. So that means we got to graph both of these inequalities. Now, they look like y is equal to mx plus b. They're not a line, they're inequalities. So you're going to have to figure out what is my m and what is my b. Now, I'm going to color code this one blue and this one red. So my slope for this one is going to be -5 over 2. My b value is going to be +4. My m value for here is 1/2. And my b value is going to be -2. Now, let's see. We got to graph these inequalities. Now, let's see. Graph the blue one first. So the blue one is at 4. And I got to go down 5 over to the right by 2. So I need to go down 5 and to the right by 2. So where's down by 5 to the right by 2? So this is 4. This is 2 right here. There you go. Down 5 to the right by 2. So that's going to be about right here. And again, go in the opposite direction. Instead of saying going down by 5 to the right by 2, you're going to go up by 5 to the left by 2. Now, I got to ask you, is this going to be a solid line or a dashed line? This is going to be a solid line. So that means I got to put a straight line, solid line. Gonna go straight. Whoops. Again, it doesn't have to be super perfect. Hopefully you see that line. There we go. Now we got to go for the red one. So we are at -2. And then it went up 1 to the right by 2. So this is the pattern. Again, you can do this. Okay. Now I got to ask you, is this going to be a dashed line or a solid line? This is going to be a dashed line. There's no line underneath. That means it's going to be excluded. So I need to put dash. This is perfectly fine. Make it very clear that it is not closed. Make it very clear. And again, you can always say solid. And this is dashed. If you say this, I'll be very happy. And your future teachers will be very happy because you're going to be dealing with system of inequalities in general in IM3. So trust me, your teacher will be very happy. Okay. Now, the blue one. Can you take a guess on if it's going to be... Actually, let me do these points right here so I don't spoil the fun. I want to make sure. There's 2 ways of actually doing this, but I'm going to do it this way first. So I'm going to just graph the lines. I'm not going to shade the solution yet. I'm just going to wait. And it's a very specific type. Now, is point -2, 1 a solution to the system? What does it mean to be a solution to the system? It needs to be true for both inequalities. So how do I do this? Well, I could plug it in both inequalities. What's my point? -1 or -2, 1. Now let's see. If I put in 1 for this one, this is going to be -5 over 2 times -2 plus 4. Do some simple calculations. We're going to have a +5 right there. Then we're also going to have a 4 right here. This will be 9 is going to be greater than or equal to 1. This side is going to be true. Let me put down true. Oops. True. This side over here, you're going to plug in 1 for y, the other equation, the red one now. This is going to be 1/2 x minus 2. Whoops, I forgot to include the x. The x is -2. So -2 times 1/2 is going to be -1 minus 2. This is going to be -3 on the right side, and nothing changes on the left. Is 1 greater than -3? Yes, it is. This is going to be true. So if both points, or the point satisfies, or what do I mean by satisfy? I mean it makes it true. So both of these inequalities are going to be true. If I were to plug in this point, it's going to be true for both inequalities. So that means that point is a solution to both inequalities. Now, how can I explain my answer? Well, there's 2 ways that you can actually explain your answers. I'm going to show you both ways, or multiple ways. I'm going to show you all of them. But the first way is just showing it algebraically. I'm just going to say it is true. The reason, or I should say, not just true, it is a solution because it satisfies both inequalities. There you go. It satisfies both inequalities. This is one explanation. There is a simpler explanation, but I don't want to give the actual solution out. But I'm just going to say that this is a one possibility of actually saying that it is a solution. Now we're going to have 1, 3, or -3, sorry. Again, same idea. Plug it into both inequalities. Both inequalities need to be true in order for it to be a solution. If one of them is not true, then that means it is not a solution for the actual system of linear inequalities. So in order for it to be a solution, it needs to satisfy for both inequalities. If it just satisfies for one and not the other one, so for example, if one of them is true and the other one is not true, that means it is not a solution. If they're both not true, then that means, well, it's definitely not going to be a solution for either one. So let's plug it in. So the first one is going to be for the blue. That's -3 and 1. So I'm going to plug in -3 less than, it was -5/2, 1, was it +4, +4, oops, +4. We got -5/2 times 1 plus 3. If I were to simplify this, this will be, what is this? 3 halves? Yeah, 3 halves. Is this true? Yes, it is. This is going to be true. -3 is less than or equal to 3 halves. So that is true. Let's see for the next one. We are going to have -3 for the y, and it's going to be y 1/2 x, but x is 1 minus 2. So we got 1 times 1/2 time, or minus -2. That's going to be -3 halves. Now, -3 halves is -1.5. What this is saying is -3 is greater than -1.5. No, that is not true. Or I should just say false. it fails. Okay, so not a solution. It fails for 1. So it is not a solution. It fails for 1. And what do I mean? Fails for 1. It means it fails for one of the inequalities. It satisfies one inequality, but it doesn't satisfy the other inequality. Now, let me go and graph the actual solution and graph the actual area. And this is where I saw students kind of make a mistake. And this is a technicality. I'm sorry for this situation if you're one of those students. But all I gotta say, it would have been a lower score. But basically boosted it up a little bit higher than it was supposed to be, according to the actual rubric that all the IM1 teachers used. So I apologize for that situation. Now, this is saying y is less than or equal to. When you say y is less than or equal to, which side are you shading? Y is less than or equal to. That is shading below. So that means I'm going to shade which direction. Hopefully you could spot the difference. A or B? Which one do you think is above the line? Well, I'm not sure if you could tell. I can't really tilt the screen, but if you were to go sideways, like tilt it, you would see that A is going to be above the line. So that means I'm going to be shading in this direction. I'm going to move an arrow. I'm going to use these arrows. The reason why I use these arrows for the other ones is because of this reason right here. I'm going to show that I need to shade it downwards. This is just making a mental note for me. So when I actually do shade the actual solution, it is only going to be shading downwards in the blue direction. So below the blue line. Now for this one, the red one, where am I going to shade? It's going to be shading above the line. When you see y is greater than, you're shading above the line. So let me shade above the line. That is this direction. Above the line. This direction. Now, I saw this. And I apologize if you're one of those students. Shading below the line for the blue one and shading above the line. Now, if you're one of these students that did this, this is a technicality. You only shade in the solution. So you do not shade in anything else. When you ask what is a solution for a system of linear inequalities, it is only going to be the solution that overlaps. And that is this section right here. I want to circle it right here. This region, if you will, is going to be the solution. Only this part. So sometimes if you saw in the actual test, I circled it and I said the word only. That meant that you were only allowed to shade in that section. What this is telling me, I know some people actually use different colors, and that even pained me a little bit more to actually mark it not fully correct. But again, you can only shade in the solution. The solution is only the actual answer, only the shaded region. And if you shade in, you can use different colors for a different thing. You have to only shade in the solution. So where is the overlap? That section that I did right there. I'm going to use the color purple. So all of this section right here is a solution. If you shaded it anywhere else, that will be incorrect. I apologize for that situation. I know some of you got the actual directions correct, but it's a technicality. Only the solution is going to be the overlap. That's why I was drawing these arrows. If you just draw the arrows, that is technically not incorrect. This is just a notation. This is just a guide for us to actually see where am I supposed to shade. If you just did the arrows by itself, no shading, that's still technically incorrect. You need to make sure that you shade in the solution. Shading in the solution is the only way to know that that's the actual answer. You need to make sure that you are shading in the solution, only the solution, and that's the overlap. Hopefully that there's no questions about that situation, and if you made a mistake, hopefully you do the retake and it will be an easy fix. Now, I mentioned that there was another way to actually get this solution. Now, since I said that this is the only section in this purple side to be a solution, well, guess what? I can, instead of just plugging the values in, I could just see if it's in the region or not in the region. That was also a valid argument that you were able to make. You were able to, I prefer this way because it's a little bit different knowledge that you're actually getting tested on. In my opinion, I would, in the future, I would change the question slightly. I would say, is the solution, or is this point is a solution? Explain your answer algebraically. That's what I would have changed. But since it just says explain, you can explain it this way. So since I know that this is a region, where is negative? I'm going to circle. I'm going to use, let's see. It's a blue point. Okay, yeah, blue. I'm going to use light blue. So I'm going to use light blue for -2, 1. So where's -2, 1? That is this point right here. Can you tell me where is this light blue point located? In the solution. It's in the region. So that means it is a solution. You could have said that yes, it is a solution because it's in the region. So if you said that route, I gave you full credit. There was a couple students that actually did it that route. It's a little bit simple, but in my opinion, I think this is a better explanation, and I would have changed the wording of the question because I wanted it to be this way. That was the intention for this question, but a mistake happened. But I accepted either way. And on the retakes, I'm going to accept either answer because that's a valid argument, and I didn't go too detail about the specifications about it, so I'll accept either one. If you said that it is a solution because it is in the region, or the overlapped region, if you will, if you want to say that, that is fine. And where is negative? I'm going to use red for 1, -3. Where's 1, -3? That is right here. Do you see this point right here? This point that I'm circling, this point right here is 1, -3. Now 1, -3, yeah, sure, it's in the blue shaded region. You see how it's in the blue side? I said that it needed to be below the blue line, but look, it's not above the red dashed line. So that means it is not a solution. In this problem over here, we actually proved, look where it was true. What is this equation true for? For the blue one. And which one is it not true for? For the red one. So it shows that it is true for the blue, but not for the red. This is an example of showing that it is a solution for one, but not for the other one. But the question is, what is the solution? Solve the system of linear inequalities graphically. Your job was actually to see the solution, not part of the solution to both of them. So if you needed to actually have a solution, it needs to be in this, in this purple region that I'm circling in red. This whole thing is your solution. So that was a common mistake that I saw, and I apologize for that situation. Now, let's see. We have... Okay, this is going to be exponentials. This is for the table and graph portion, and then also write and evaluate exponential functions as well. So let me show you. You're going to see a question that is, all of them are going to be, I'm letting you know right now, write down this equation right away. It's going to be y is equal to a times b to the power of x. All exponentials, at least for this class, is going to be always in this form, every single one. Now, I tend to always write down the equation first because it makes things a lot easier. Again, write down your equation. An equation, please do not write an expression. So I want to explain what I mean by an expression. So A is always going to be your starting value, what you start off with. Now, all these type of questions, they're always going to say either it's going to be starting with a certain amount of money, starting with a certain amount of investment, the car value, gallons, or some type of measurement that you start off with. They're all going to say something that you start off with, and that's going to be your A value. So I'm starting with 450 gallons of water. And then right after that, they are going to tell you something that says empties, fills the pond, fills the pool, it increases investments, it increases the value, some sort of increasing or decreasing. It's going to be some type of rate. Now, when you say increase or decrease, you are increasing or decreasing from 100%. Now, it is either going to be going above 100% or below 100%. And it all depends on the wording it says. In this case, it says the word empties. When you think of emptying, do you think of increasing or decreasing? Well, hopefully you understand that it is going to be decreasing. So you're losing 17%. So that means you're going to subtract 17% out of 100%. 100% minus 17% is going to be what? Hopefully you answered this correctly. This is going to be 83%. So when you subtract 17%, it is now going to be an 83%. How do I write down 83% as a decimal? Well, the best way to do that is just move the decimal twice. Boom. It's going to be 0.83. You move the decimal 2 places to the left. That's how you're going to be able to write down a percent as a decimal, just in case if you forgot. So this is going to be times, and if I want to be super accurate, extremely formal, I got to put 0.83 if I want to be super accurate. If you put 0.83, I'm guilty of putting 0.83. It's just a habit that I do. So it's okay. I'm not going to mark you down. I get that you're actually doing 0.83. I do it too. I'm not going to mark you down. That's a minor thing that I will not mark down for. Now, this is your equation. 450 times 0.83. 0.83 is your multiplier. That is what you're multiplying every single time. And you're talking about you're losing 17% each day. So these are all day values. So I need to plug it in one at a time. So how do I do that? Again, I'm going to use not sponsored, by the way, even though that they should sponsor me. This is going to be 450 times 0.83 to the power of, well, I got to do the first value. The first value is 0, but again, the 0 term is always, or the 0 value, I should say, for the x value, the starting point is going to be 450. So that should be 450. That should be a given. Now, the next one is going to be, next point, 3.3 or 373.5. So 373.5. That is my next point. I got the next point over here. Oops. 2. I got this answer over here. Now, I'm going to write down all these answers. All I'm going to do is just do it on the side. I want to write these answers down so I don't forget them. But all I'm doing is just going to write down these answers down one by one. So you can do it on your calculator one by one. So let me do the first one. The first one was actually the easiest one because it is your starting value. So that's going to be 450. The next one is going to be, I forget which one it was. It was like 3 something. 2, let me see. Yeah, 373.5. We plug in 2. This is 310.005. If I put in 3, some of you are probably commenting on something. I will hopefully let you know in a moment, but I want to show how easy it could be missed. If I plug in 3 into that same equation, what I was doing, this is going to be, it's going to be a long one. 213.5624445. The next one is going to be for 5. 177.2568289. Okay, some of you may have been commenting already. Hopefully you don't blast the actual comment section. But again, a common mistake that I saw students do, and it's such a subtle, please be careful about not reading or not forgetting to read the entire question. I purposely left it out. What does this say? I'm going to highlight it in red. It says round your answers to the nearest 10th value, that the nearest 10th. Now, where is the cutoff for the 10th value? That is going to be all of these values right here. And let me go down. Let me use the 10th. Let me highlight the 10th value. There's your 10th value. Now, how do I round? I got to look at the next number, and if it's greater than 5 or equal to 5, I'm rounding up. If it's less than 5, I'm going to go down. So let me, oh, that's a horrible 5. Let me rewrite this thing. Sorry. Let me rewrite that 5. So this is going to be just still 400. This will be 373.5. This will be 310.0. There's no change. If you put 310, that is perfectly fine. This one will be 257.3. This answer will be actually 213.6. This answer will be 177.3. These are going to be your answers. Make sure that you are only putting in the rounded answers. Now, I recommend that when you're actually plugging these values in, that you're not just rounding as you are going. Say, for example, if you plug in this value, 373, and then you multiply by 0.83, because that's what you're attempted to do, and then you get this answer, and then you round, and you put 310, and then you round again, you're going to have a rounding error every single time, and that will affect your final answer right here. So always use the equation and round from the equation, not round your previous answers and then just multiply by 0.83, round, and then multiply by 0.83, then round. Always use the equation. So let's see, we got to plug in these values. So this is going to be a little bit kind of hard. These are not perfect, but I was looking for a specific type of graph. You need to make sure that you are able to prove the actual graph and make it very clear. So 73, that's about right here, I would say. 310. Again, this is not 100% accurate, but I just wanted to show a specific point that I'm gonna try to make right here. Am I missing something? Oh yeah, I missed 1 point. Whoops. This is actually 213, and this is 177. There you go. So this is the actual graph. I missed the actual number. Whoops. Now, you might be tempted to try to, again, the graph is not 100% accurate, and if you're not very careful, you might be just tempted to just draw a straight line. Now, what type of equation are we dealing with? An exponential function. An exponential function has a curve to it. All exponential functions will look either going up like this or going down like this. Now, it is not a straight line. If you drew a straight line, that is a linear function. That is not the same as an exponential function. And on the rubric, if I see a line showing up, that is an automatic 50%. So, linear functions, a line is not the same as a curve. They're completely different types of functions. So be careful. Now, the way that I wanted you to do it, and that's what I mentioned, always make the curve. Even though you can't make it perfectly, make an effort to make a curve. This is perfectly fine. I know it's not 100% the best curve, but I can see the curve in this shot, this scenario. I see a curve. Now, I don't need you to go like going down. I'm going to write it in red. I don't need you to do this. That'll be incorrect. You need to be kind of following the pattern. I want you to show that it is going to be going in a specific pattern. And that's going to be kind of a slow curve like that, because it's slowly going down as you are emptying the pool every single day in this context for this problem. Now, it's also asking you to, this is for this section right here. This is for the table and graph. That's for the upper portion. Now, write the equation for an exponential graph and also evaluate the exponential function is going to be for that bottom portion. That's why you saw two different, I guess, grades that you saw in this same exact question. So the bottom part is for one side of the equation, and then the top part is for one side of the other part of the equation. Now, this one that we have, we just need to plug in 35. Let me go back to my favorite calculator, not sponsored. Plug in 35. And look what we get. 0.662. Now, I needed you to write down your actual work. Please make sure, it might be redundant. It might be not the best time. But please make sure that you are showing your work. You need to show your work. Plug in 35 because we're talking about days right there. So that's why I plugged in the 35 right there. My answer was, oops, where is it? It is going to be approximately 0.662133783. Now, what is the question asking you? Let me highlight it again. Super easy. You might be tempted to skip the actual, read the entire question. So please make sure. It says round to the nearest 10th. The 10th value is right here. Whoops, let me highlight it in red. That part. This part is the 10th value. So that means you need to go to the next one and see if it's going to be going up or going down. So this is actually going to be going up. So this is going to be 0.7. Is it gallons? Gallons, yes. It is going to be 0.7 gallons, 0.7 gallons. This is your answer. Hopefully this answers your question. Okay. So next thing is basically writing. I believe the section is called, let me not misquote it. This is a one-page one, so this one is a lot easier than the rest. Let me see, which one is it? Do I not have it? Where am I? Thought I took a copy. Oh, I guess I didn't. I think it was writing an exponential equation from a situation, exponential functions from a situation. I think that's what the name of the title is. I forgot. But yeah, it's a situation. Again, I suggest that you write it down. y is equal to a times b to the power of x. Now, every single exponential in this class is going to be written like this, every single one. There's always going to be some type of starting value, and there's always going to be either a growth or a decay, just like what I said over here. You're starting at 100%, and you are either going to be going up or you're going to be going down. Now, in this case, what am I starting with? Well, I'm starting with 51,000. And what am I going up by? 7%. So if I were to go up by 7%, I'm going to be at 107%. How do I write down 107%? It's going to be 1.07 for that multiplier. That's going to be your b value. And you're going to have y is equal to 51,000 times 1.07 to the power of x. That's straightforward. That is your equation for this problem. I actually didn't talk about it before. When it says equation, write the equation. I saw students do this. Unfortunately, this is called an expression, not an actual equation. An equation has an equal sign. It has an equality. Doesn't matter. You need the equation. When you write an equation, you need that equal sign. You can have an equation and it could be false. That's fine. You can have a false equation, but an equation needs that equality symbol, that equal sign. So if you just had this part, you lost points. Please, even says it in the problem, write the actual exponential equation. You need to write down the exponential equation. Make sure that you are actually writing the equation. Do not just write down an expression. If you just write down the expression, it is technically not an actual correct answer. So if you want to write down the exponential function, it needs to be an equation. So exponential function right here is what you need to write down. This is your exponential function. This whole thing that I just circled right there. This is an exponential function. So please make sure that you write down the equation. Don't want you to lose points. Now this one, again, hopefully I don't need to do that much. We got 1500. That's your starting point. And it says the word decay. Now, when you have something that is decaying, do you think you're going up in percentage or going down in percentage? Well, you're going down. So that's going to be from 100%, and you are going down 12.7%. And if you were to do 100% minus, let me put down let me erase this part right there. Going down 17 or 12.7%, your answer is going to be 87.3%. Now, how do I write down 83.3%? Well, move the two decimal places and you're going to get 0.873. That is going to be your multiplier. This is going to be 0.873 to the power of x. This is your exponential function from these two, or well, this situation. These are the answers for both situations, for A and B. Hopefully there's no issues. Everyone, hopefully if you're watching this, type in cat in the comments. You're doing good. Okay. Now, this question number 6. This is going to take some time. This is going to be writing the equation from an exponential, or writing the equation of an exponential function that goes through 2 points. So you need to write down an exponential equation that goes through these 2 points. It looks scary that they're so huge, but do not worry. The same process will always happen. If you follow these steps, hopefully it will be a lot easier. So first thing that you need to do, what is the equation of an exponential function? Y is equal to a times b to the power of x. Let me write that down here so we have it ready to go. Y times b to the power of x every single time. Your job is to find out what is my a and what is my b, because I want a nice equation, just like what we have over here. These are nice equations. We want these equations. Now, 2 points. I want to say that this is going to be the first point in blue, and I'm going to write down this one to be in red. Now, the first point, I'm going to use the equation. So we got 500. I'm replacing y with 500 for the first point. We got a times b, and what is my x value at the first point? 3. So I'm plugging in 3. So you're understanding where I'm putting these values in. The next point that I'm going to be using is going to be 62,500, and it's going to be equal to a times b to the power of x. But what is x in this scenario? 6. So I color coded it so it makes it a little bit easier to see what's going on. I'm going to rewrite these equations right below it. So that is for this section right here. That is my work for setting up. If you set this up, bare minimum, I think a 75%, if I'm not mistaken. If you just set up these equations and did some type of attempt to actually solve the problem. If you just, if you just set up these equations just like this and attempted to solve the problems, I gave you 75%. That's at least a good effort and the correct setup as well. Now, this is going to be 500. 500 is equal to a b to the power 3. 62 500 is equal to a b to the power of 6. Again, I always tend to put these parentheses around. My goal is to get a by itself. Now, you need to choose which one that you want to get a by itself. I always tend to get the lower exponent for b to get that equation a by itself. You can do whatever that you want, but I found that if you do it this way, you don't deal with these negative exponents, which you do not want negative exponents. You want to get rid of negative exponents as much as possible. So how do I get rid of negative exponents as much as possible? Well, guess what? Actually, we're not going to be able to do it in this problem, but hopefully another problem that I'm going to be making up on the spot, I'll be able to do it. So for this problem, there's no negative exponents, so handle negative exponents first if there is any negative exponents. That is going to be for, in this case, right here or right here if there's negatives. Now, since there is no negatives, I always go for the bottom or the lowest number for the exponent. So this is exponent 3, exponent 6. So that means exponent 3 is lower. So that means I need to get this a by itself. Divide by b to the power of 3 on both sides. I want to get a by itself. That is my goal. A by itself. So divide by b to the power of 3. That means right here so far a is going to be equal to 500 divided by b to the power of 3. That's what I do know for sure. Now, I have this equation to the right. I'm going to plug in a into that second equation. So I'm going to plug it in, and this is what I want to get. So let me plug in this equation into the other one. I'm replacing this a right here is the same a as over here. A is equal to a, b is equal to b, same exact a. But what is a equal to? This left side right here, 500 divided by b to the power of 3. So that's what I'm going to do. I'm going to have 62,500 is equal to 500 divided by b to the power of 3 times b to the power of 6. Now, you got to use your exponent rules for this situation. What is b to the power of 6 divided by b to the power of 6? Let me put it down over here. B to the power of 6 divided by b to the power of 3. This turns into an exponent rule. This exponent rule is x to the power of m divided by x to the power of n. When you have the same base, all you need to do is subtract the exponent, m minus n, top exponent minus bottom. In this case, this is going to be b 6 minus 3, which is b to the power of 3. Another way to look at this as well is how many b's do I have at the top? I have 6 of them. How many b's do I have at the bottom? That's a horrible b right there. That looks like almost like a 6. There you go. How many b's do I have at the bottom? 3 of them. So if b divided by b is 1, that means, well, how many do I have left? If I were to have 6 b's, I'm just explaining this side comment, so hopefully I just need to do it one time. Doesn't need to happen again. If I have 6 b's at the top and b divided by b is 1, so all of these are 1, 3 of them. How many do I have left? 3. And where are they located? At the top of the fraction, the numerator. So that's going to be b to the power 3. So if I were to simplify this down, this is going to be 62,500 is equal to 500 b to the power of 3. I'm simplifying as much as I can. Now, I need to get b by itself. So how do I get b by itself? Well, there is a multiplication that's going on right here. 500 b to the power of 3 is the same thing as saying 500 times b to the power of 3. Now, I need to divide by 500 on both sides to get b to the power of 3 by itself. So b to the power of 3. Now, I gotta plug it into this calculator. Let me see. So 62,500 divided by 500. That is 125. Oh, I should have done that by 2. It should have multiplied the top number by 2. Again, if you can find faster ways to do this, but it's a little bit late right now, so I don't plan on doing this. But it's 125. You're going to have a calculator for the actual test, so don't worry, you will be having a calculator. Now, I recommend that you, again, not sponsored, but get this calculator. It is super nice, and you can see the fraction perfectly. So parents, can't force you to buy it, but you get a math teacher approval for this calculator. At least one teacher, as you could say. So now I need to get b by itself. B by itself. I have b to the power of 3. I need to find out what number times itself 3 times gives me 125. Or, well, sometimes you're not able to perfectly see it right away. Sometimes it's easy, like this one. I could see some students can figure out the number right away, but if you can't, well, you're going to have a calculator. You are going to be doing the cube root on both sides. So let me actually write this down on the side right over here. So 125 b to the power 3. What you are going to be doing is not doing the square root. This is called the cube root. This number right here is to the power of 3, b to the power of 3. That is your exponent. Now, you see that number right there, right, the red 3? That is going to be, that number is called the index in that radical, or basically the radical right there that you see. This 3 is called an index. The index has to match up with the same exponent. Say, for example, this was, say, 7. That means that I got to do the 7th root. Say that this was 8. Then I got to do the 8th root, and so on. This is 3, so this needs to be 3 as well. They need to match up perfectly. Now, when you do the 3rd root of something that is cubed, they're going to be called, you're going to learn the actual technical definition in IM3, but they act like inverses of each other. They're like opposites. That's basically what you need to know for right now. They undo each other. When you cube something and then you cube root it, you're undoing the operation. So if you say multiply by 2 and then you divide by 2, multiplication and dividing, they're kind of like opposites of each other. They counteract with each other. That's what's happening right here. So they're undoing the operation. So you're going to have the third root of 125. Now, you're going to be given the actual school calculator. Don't recommend that calculator. But again, parents, not sponsored by the way, but I recommend. You see that little square root symbol? Perfectly shows. And it, look how pretty this calculator shows the actual answer. And perfectly put the answer in. So, highly recommend this calculator. Not sponsored, but highly recommend this calculator. Parents, please trust me. This is a very good calculator. Not sponsored, by the way. So my answer will be B is going to be equal to 5. Now, I got to see. Let's see. We have B is equal to 5. I got to plug it into this equation because I needed to find out what A is and what is B. Well, I already know what B is. It's equal to 5. And look what I have. I have A by itself already. So all I need to do is plug in 5 into that equation. So this is going to be A is equal to 500 over 500 over B to the power of 3. Now, that is saying 5 to the power of 3. This is going to be A is equal to, well, I can do this part right here because we already did it right now. We have 500. What is 5 to the power of 3? That is actually 125. And then we do 500 divided by 125. That will give you a nice number of 4. And again, you do not need to do all these calculations. You can just let the calculator do the work if you want to. But I just, again, not sponsored. Let the calculator do the actual work. See how perfectly that looks? 500 divided by 5 to the third power. Look what happens. It gives me the answer perfectly. And I know that I'm putting it in correctly. So my answer will be 4. A is equal to 4. Now, how do I write down my equation? Well, my equation is going to be y is equal to a times b to the power of x. How do I write down my equation? It is going to be y is equal to, what is a? 4. What is b? 5. This is my answer. Y is equal to 4 times 5 to the power of x. Okay, so this is, yeah, that's pretty much the entire test for version A. Okay, so I did a full detail on version A. I am not sure if I'm going to be able to do another one and get a good night's sleep, because if I need to do version B and also version B and also explain the variations of them, I'm going to be here all night, and I want to make sure that I get at least some sleep for tomorrow. So what I want to do is I want to quickly try to do version B as fast as I can. Hopefully I do not make any mistakes. That'll be very embarrassing because that's going to be on the internet. So I'm pretty sure I'm going to be on the internet, especially at the beginning of that video that you saw me do with the dancing with the cat. I'm pretty sure that few of you will be putting that on TikTok. Please, don't make it sound too bad, but it is what it is. I'm going to be just accepting that situation. Hopefully that made you put a smile on your face. That was the intention. Now, same thing. I want to be going over the problems. I'm going to go quickly. I'm just going to go do it quickly. Again, you got to do plus or minus. You have to get the absolute value by itself. You're going to have -5. Was this actually the same questions? Yes, it was. Oh, wait, oh yeah, it was the same questions. Wait, is it? Hold on. No, it was slightly different. I think it was. Yeah, no, it was slightly. Okay, let me just do this. So we got 1. We got -3 on the other one. We got -5 plus 1. Switch the sign. -3. Again, subtract 1, subtract 1, subtract 1 on both sides. This will be -5x. We got 2. Divide by -5. Divide by -5. This will be x is greater than -2 this. Whoops. There you go. And let's see. We will be going this route to be -2 fifths. And we are going to be increasing in value. So going in this direction. Now I got to see where is this side. So we're going to see we got -4 on this side. We got -5. X divide by -5. Divide by -5. X will switch the inequality. This will be 4 fifths. I could have sworn that I think this is the same exact. Is this the same one? I'm going to do less than. So that means the solution is in between. This is my solution. Let me see. Is this the same one? Yes, it is. Whoops, I just did the same problem. But either way, it's okay. So this one hopefully is different from a letter B or version A. So again, add. You need to get the absolute value by itself. Only way. So you're going to have -1/4 x plus 1. And then this is going to be 13. You will need to do the split on both directions, positive and negative. You're going to have -1/4 x plus 1 greater than 13. This will be -1/4 x plus 1. Switch to inequality because it's going to be the negative side, and -13 on this side. Then I'm going to be subtracting 1 on both sides. I will get -1/4 right here. This is going to be, we got negative or positive 12 right here. Then I'm going to multiply by -4 on both sides. When I multiply on both sides by -4, the inequality switches directions. So this is going to be -48. I want to say that this is -48 over here, so just -48 right there. Same thing on the other side, -1 on both sides. Same type of operations, just different numbers. We're going to have -14. We got -1/4 x. Multiply both sides by -4 on both sides. So we got -4 times -14. That is, what is that? We got x is equal to, whoops, it's going to be switching sides. Whoops, let me write that down. Switching side, that's going to be positive 56. So I'm just going to say that this side is 56. I'm just going to say that this is 56. This is going to be, oops, there's a line underneath. That was a whoopsie. Close circle, close circle. If you caught that mistake, good job. Moving quickly. Hopefully you understand that part. Again, you want to get the absolute value by itself. Main key idea before you can split. That's the only time that you're able to split. Over here, I'm going to do a couple things at the same time just to simplify things down. I got to add 1/5 x to both sides, and I'm going to add 2 to both sides. This is going to be 21/10 because 20/10 is 2. 20/10 plus 1/10 is 21/10. Again, if you're having any issues following, just slow it down. I need to make sure that I go to bed early enough. Multiply by 5 on both sides. This will be, we got 21/2. We got 2x divided by 2 on both sides. Again, we talked about that fraction situation. This is going to be 21 over 4. And then this is going to be is less than x. So where is going to be, I'm just going to say that this is 21 over 4. Again, you could pick wherever that you want. Open circle, and it's going to be going increasing because it's greater than, it's going to go in that direction. And hopefully you got that answer. We got minus 9 on both sides, minus 9 on both sides. We got negative 7 on this side. We got 1/3 x on this side, multiply by negative 3 on both sides. We have 1, okay, that's a 1 right there. We got x is going to be a less than, because I multiply both sides by a negative number. That means I got to switch the inequality. This is a 21. So I'm going to have a 21 right here, a closed circle, and I'm going to go down this direction. So hopefully everyone is following along. Same thing over here, very similar to what we did. Y is equal to mx plus b. You kind of treat it like a line. It's not a line, it's an inequality. It's a two variable inequality, which is going to be a line. So we're going to have this line over here. I'm going to draw it in red so it's a little bit easier to see. We got positive 2 for the b value, and then negative 3/4 for the slope. So we're going to go down 3 to the right by 4. So that's right here. Down 3 to the right by 4. That is the same thing as going up 3 to the right by 4. Let me see. That's about right there. This is a dotted or dashed line. Please make sure that you make it very clear that this is a dashed line. And which way am I facing? I'm going to be going y is greater than. We talked about it in the actual notes. When you say y is greater than, or y is greater than or equal to, you're shading above the line. So where is above the line? If I were to say that this is A and this is B, well, which one's higher? A is going to be higher. So that means you are shading above the line. All of this is going to be shading above the line in this direction all the way across. So this is going to be the shaded region. Again, make sure that you only shade in the solution. Now for this one over here, okay, so let me do this quickly. Okay, oh, this is going to be a nice numbers. Okay, so we got x and y. So again, I use -2, -1, 0, 1, and 2. Again, we got to plug it into the calculator. So if I were to plug in -2 into this equation, my output should be, what is that, 40? Okay, so it's going to be 40. And since I figure out what the first point is, and I'm constantly multiplying by 1/2, so that means I'm just halving every single time. If I plug in -1, I'll get 20. Then if I plug in 0, it should be 10, which is the starting value, so that should make sense. If I plug in 1, that will give me, oops, I should get a 5 right there. This will be 2.5, and there is your 5 points. We can't graph the other points, so we're just gonna have to use 3 points. So this is 1.5, this is gonna be 2.5, and again, it's not gonna be 100% accurate, but it's gonna be something along the lines like this. I'm gonna color code it red, or actually blue, sorry. It's going to be something along the lines like this. Try to make it very clear on where you're going to be graphing. And again, you will have to graph below the line. The reason why is because, well, we got less than or equal to. So less than or equal to is in this direction. So going down, that is all of this direction right here. And again, just to emphasize, it's a good habit. Just say that this is a solid line. Make sure that it is very clear, because some of you write down dash lines that look like they are solid. So make sure that it is very clear that it is either dashed or a solid line. Do not want to have any issues. So next one, we are going to be working on the system of linear inequalities. That is going to be two inequalities, and you're only graphing the solution. Now, I'm going to be doing the shorter way so I don't have to go about it again. If you want to do the longer way, you can. That's up to you. I'm going to graph this one to be blue and this one to be red. So the blue one, it is going to be -4 right here. We go, oh man, this would be annoying. Okay, I got to count this one out. Let me look at this. Okay, so this is, okay, 1, 2, 3, 4, 5, 6, 7, 8, and then 3 across. That is this point right here. Unfortunately, there's only 2 points. This is the best we got. It is going to be a dashed line, so I'm just going to do a dash right here. Not 100% perfect, but hopefully, oh no. This is the downside. Some of you actually are aware of the situation. Sometimes it gets deleted, so I think it was around these 2 points if I'm not mistaken. I erased some of the actual work, but hopefully it is a video so you can go back and just see the actual solutions, because all this shading is incorrect. I think it was something like that, and you shade it down and then you shade up over here. Sorry, it was deleted, but sometimes that happens. You are aware of the situation. Okay, so in this case you're going to be shading upwards because you have y is greater than, and this is going to be shading downwards of the line because I know it's y is less than or equal to. So let's graph that red one. This is going to be this spot right here, 1/3, 1/3, 1/3. It should be about this situation that I'm drawing right here. It's a solid line because you have the line underneath. It's included. Now, if it's included, it's a solid. Now, if it's excluded, it is going to be a dashed line, and I'm going to be going downwards. So the blue line, I'm going upwards, up on the graph, and then on the red line, I'm going to go below. Only shade in the solution. Now you might be wondering, where is the solution? That is all that I'm shading right here. Again, you do not need to be perfect on the shading. I know it's not perfect. You can see that is not perfect. I don't mind if it's not perfect. All I care is it shaded correctly? Is only the solution shaded? Do not shade in all of the sections that will make it true for one of them. Only the solution, which is going to be for both of them, the overlapping regions, is going to be the solution. So please make sure. Now you can test like what I did on version A over here by plugging in one individual point at a time, but I'm just going to say we can just see where it is. Okay, let's see. 3,1, that is this point right there. I'm going to color code this point to be, say, teal, right over here. So 3,1, that is this point right here. Is this a solution? No, it's not. It satisfies the red one, but not for the blue. So that means it is not a solution. It is not in the region for the solution, so that means it is not going to be a solution. So it's going to be a no. Now this bottom point, -3, -1. Where's -3, -1? That is this point right here. Clearly, it is going to be inside the shaded region. So is it a solution? Yes, it is, because it is in the shaded region. You need to make sure that you explain your answers. Please do not forget your explanations. I know I said it right now. I did not write it down. But again, I'm running out of time because this is 2 hours and 4 minutes long. Sorry for that, but hopefully it's good enough detailed explanations. Question number 4. We have an exponential scenario that's happening, and for this scenario we got 150 gallons. All exponential equations, please remember, is always going to be y is equal to a times b to the power of x. Y is equal to 150 because I know it's 150 because it starts, even says started with 150 gallons. And what's happening right here? It says it is filling the actual pond by 16%. So when you are saying filling up the pond by 16%. You are going up by 16%. So that's going to be 116. How do I write down 116 in a decimal form? If I were to plug that in, this is going to be 1.16 to the power of x. Now, when you plug it into the calculator, please make sure that you round to the nearest tenth. I'm going to put it into my calculator. I can't show you, not sponsored by the way. My favorite calculator. I'm going to plug it in one by one and see what my actual results are. So the first one, it should be easy because it's already given to us. It's 150, but if I plug in the next one, it's going to be 174. If I plug in the second one, that is going to be 201.8, round to the nearest 10th place. This is where it's going to start showing the actual rounding occurring. So this is going to be 234.1. If I were to plug in a 4 into the equation, this is going to be 271.6. And if I were to plug in a 5, this will be 315.1. So my goal is to, let's see, plot this point. So we got 150. I want to use blue so it makes it a little bit easier to see. 174, that's about right there. 201, that's about right there. 334, I'm just going to say that's right there. Again, this is not perfectly to scale. 4 is about 271, that's about right there. I'm just going to say that that's right there. Again, it's not 100% accurate. I would say this is actually above because it's 34. This should be 25, so it should be more like this. Sorry for that. Again, it's not 100% accurate. Try the best you can. We got 5, 315. That's about right there, I would say. Again, you want to make a curve as much as you can to make it very clear. Whoops. Make it very clear that it is going up. Again, this is an exaggeration on this curve, but at least I know it's not a straight line. Make sure that you are very clear if it's going to be curving up or curving down, but not below the x-axis, as what I discussed earlier. If I were to plug in this equation, so this is going to be y is equal to, oops, this is going to be y is equal to 150 times 1.16 to the power of 14. If I were to plug that into the calculator and round to the nearest tenth, it'll be 1,198.1. This should be my answer. So that is going to be for my, it's going to be in gallons. Okay. I'm rushing too much. I should do a little bit better in my penmanship. So there you go. There's your gallons. And for writing the exponentials, you're going to be needing to make sure that you have the actual equation of in exponential function. You need to make sure that you have it in this form. Please do not write a linear equation. I saw that happen. So again, we're going to have our starting value, 15,400 times, and you're talking about growth right here because it says growth of, or grows at 18%, grows 18, or I should say 8% each year. I should not include that 8%, but it's okay. We got 1.08 to the power of x. We have over here, we have 350, and we are decaying 10.7%. So if I were to do 100 minus, whoops, not eraser, 100 minus 10.7%, that is going to be 0.89.3 to the power of x. That is going to be for problem number 5. Now for letter or number 6, again, the same idea, the same approach. Let's see if I can get through this very quickly. We got y is equal to a times b to the power of x. Now, let's see, we have these 2 points. I want to color code just to emphasize the importance of knowing which is which. So the first point is going to be 63. Again, I am plugging in x and y for my first point. So y on the first point is 63. Then I have a times b. And what's my first point for the x is going to be 2. The second point is going to be 1701. And this one's going to be equal to a times b to the power of 5 right there. It's supposed to be in red. This is what I have for this equation. Again, I'm just going to write it down on this side over here. I'm just showing you what it's supposed to look like. Let me just have it right here. I tend to use the parentheses as much as possible because I see mistakes happen. It's just a preference that I do. I love using parentheses because it makes things very clear about what is my actual exponent, especially in this form. Makes things a little bit more clear. So hopefully everyone got this information. You can always pause it, rewind it, or watch the better explanation that I did in the first version A. Now, this is going to be, let's see. Again, I always recommend that you actually solve for A. Get A by itself for the lowest exponent for B. So in this case, we got our lowest exponent right there, 2. So we're going to get this 2 by itself. Now, divide by b squared. Oops. B squared on both sides. This is going to be divided by b to the power of 5 on both sides. We will have a is equal to 63 divided by b squared. This is 1701 divided by b to the power of 5. We got, what did I? Going so fast, I'm not even thinking. Again, I want to plug this equation into this second one. Whoops, sorry, I'm not sure why I did that. I was thinking about another student. Someone showed me a different way to actually solve this problem. Yes, it is correct. I was just thinking about that right now. Thinking about for that specific student. If you see this part, I was thinking about you because of what you showed me today. Again, every single teacher teaches slightly different. So if you went to a different teacher that is also teaching IM1, she is teaching it slightly different, but it is still correct, just to let you know. Okay, now let's see. We have to combine these b's together. B to the 5th power divided by b to the 2nd power. This will turn into 63 times b to the 3rd power. Then I got 701 on this side, and then divide by 63 on both sides. I'm not that good at math, so I'm gonna have to use this calculator. So b to the power of 3. I'm not that good. 1701 divided by 63. That is going to be a nice number, which is good. Like I planned. It's going to be 27. The opposite of cubing something is going to be square rooting something. Again, I'm just going to emphasize that point by showing you the next step over here. This is going to be 27 on this side. The cubing on both sides. I should write that 3 a little bit better. So this is cubing. Again, if you see an exponent of, say, 5, you need to do the 5th root. If you see an exponent of 7, you need to do the 7th root. So you got to match the index, which is this number right here, and the exponent. You need to match them up perfectly. This will be b is equal to the cube root of 27. And again, not sponsored. Parents, please make sure that you try to get this. We got the cube root of 27. That is going to be 3. Look how nice this looks. Again, I want to emphasize how nice this calculator is. Not sponsored, but should be getting paid from them. Free advertisements. So b is equal to 3. Now, I need to get a and b. So I only got b by itself. Now I got to get a by itself. Well, I already got an equation where a is by itself right here. So my goal is to get that a answer, which is going to be plugging in 3 for B, so that's going to be 63 divided by B, which is going to be 3 to the power of 2. Now, you can do it side by side. That is up to you. You don't need a calculator for this situation. Hopefully everyone got this. You can do 63 divided by 3 to the power of 2. What is 3 to the power of 2? That is 9. Now, 63 divided by 9 is going to be 7. My equation is going to be 7 times 3 to the power of x. This is your solution for version B. A lot less explanation, a lot less detail than what I did for version A, but we did it way faster. So hopefully you enjoyed that version a little bit easier. Now, I want to talk about variations. Okay, the variations of the problems that we were working on. And I'm going to go and look at, I have some physical copies. You know what? I'm just gonna show you. I was not gonna plan on doing it, but if you're actually watching this all the way through, well, you deserve it. It's okay. So at least you can learn something. I'm not gonna be doing all the problems, but I already did a couple already because I was planning on just showing the actual answers, or I guess the solutions, not the actual work. But here we go. But here's a couple answers. Again, this is for the absolute value, and without the absolute value you still need to do both. I want to do a couple of them so you understand which one's which. So this one, again, the main goal is to get the absolute value by itself. Split it up. You got positive and negative. Now whenever you have a negative side, you need to switch the inequality. You switch the inequality, the alligator symbol, every single time that you are multiplying by a negative number or dividing by a negative number. So multiplying by a negative number or dividing by a negative number. That is when you are switching sides. Now look what we have over here. This side, there's no switch. There's a switch at the start because we got the negative side right there. So it switches and it makes a -3 as well. But look what happens over here. I divided both sides by -6, and look what happens to my inequality. It switches directions. It was facing the opening to the right, and now it's opening to the left. Over here, same thing. We are going to be opening to the right, but then once I divide by a -6, it switches directions. This is going to be my points. Again, you can choose whatever points that you would want. It doesn't really matter. So, and this was where I left off. I think I did another problem. No, or yeah, I did over here. I'll show you that problem in a moment, so give me a second. So let me just do this problem. Again, you want to get A by itself. I'm just going to do these problems with you all. If you actually are paying attention and did it all the way, make sure you like and subscribe. No, just kidding, just kidding. Okay, so we got -1/2 x minus 7 greater than or equal to 10. Then on this side, it's going to be -1/2 x minus 7. We got to switch the inequality symbol. This is going to be -10. Now, this right here is going to be the same operations, adding 7 on both sides, adding 7 on both sides. You're going to see it's the same type of operations, but just different numbers. You're going to have 1/2 x on this side, and you're going to add 7. We're going to see that's going to be 1/2 x is going to, or -1/2 x is greater than positive 17. But look what I want to do. I want to multiply both sides by -2. So if I multiply both sides by -2, what's going to be happening to both sides? It's going to be, well, this side is going to be a +1, and it's just going to be leaving with your x. But look what happens to the inequality. It switches directions. When you multiply or divide by a negative number, it switches directions. We got -2 times 17. That is going to be -34. Hopefully there's no issues with that situation. Now we got to add 3, or it's going to be -3 on the right side. and no change until we are going to be multiplying by -2, just like what we did on both sides. Multiply both sides by -2. This turns into just a 1x, so that's going to be x. And again, you're switching the sides, so instead of going from this direction, it goes to this direction over here. Divide by a negative number or multiply by a negative number, it's going to be switching directions for the actual inequality. So instead of opening to the right in this case, and then it's going to be opening to the left on this scenario. So let's see, we're going to have -2 times -3. That's going to give us a +6. So this is going to be -34. It doesn't have to be to scale. I'm just going to say that this is -34. And just to prove a point, I'm just going to say that this is, say, 6. You could put it the 6 right here. It does not matter. I just wanted to make it clear. I like to separate them, to just put it like a little bit separated to make things a little bit nicer to visually see and also to grade. So please make sure that if you can do that, that'd be very appreciative. Now this is going to be a closed circle because you have the equality. It's going to be or equal to situation. So this is going to be less than or equal to -34, so that means you're going to go in this direction, and it's going to be a closed circle again, and it's going to be greater than 6 or equal to 6. So that's why we're going to go in this direction. So hopefully you did that part. Now I want to address this situation. I want to do letter F because I think it's kind of the same thing as what you're going to be doing for letter E, G, and also H. So letter F, again, you need to have the absolute values by itself. So the absolute value by itself, add 7 to both sides. Now we're going to have -3. We got 3/5 x plus 6. I'm going to have to write down really small because this is going to be a lot of work. I gotta make it a little bit smaller. I gotta zoom in a little bit. Okay, so again, it's the absolute value by itself. You might be tempted to distribute. You're not allowed. It is not a legal operation, and there's some there's exceptions. If you have a positive, you're lucky that you're able to do it in this way, but negatives are not. That's technically not a legal way to actually do it because an absolute value will change the actual result. Now, when you do this, it'll be incorrect. Please do not distribute that -3. Get rid of it. You can only do the operation of division, which is going to be dividing by 3. -3, more specifically. I'm going to have the absolute value of -3 this x plus 6. Now, since I divided by -3 on both sides, that means this is going to be switching sides, so that's going to be -8/3. Oh, this is going to be a nightmare to actually do. Oh, I'm sorry. But I just made these problems on the spot when I was just making these actual worksheets. But I just wanted to throw everything at you, anything that's possible. Now, once I get them all split up, I'm going to have that positive and negative side. This side will be -3 this x. Oops. -3 x. We got less than or equal to 8/3. We got -3/5 x plus 6. And again, remember the negative side switches the actual inequality. So we're going to have not only the switching the sign, but now we're going to have a positive 8/3 on the right side. Now I'm going to have to subtract 6 on both sides. So when I subtract 6 on both sides, the left side is going to be -5/3 x, and then if I were to do -8/3 minus 6, if I were to do that, it's going to be -18/3. Then I would need to simplify it a little bit further, but that will be a total of, what is that, 18 minus 8, that's going to be this is going to be -26/3. Again, not the most prettiest numbers, sorry for this situation, but just trying to teach you. Doesn't matter, you're going to get the exact same result. Doesn't look pretty, but sorry for that situation. Multiply both sides by, let me do multiply by -5. negative 5 on both sides. We are going to be switching signs. We are going to be going in this direction now. If I multiply by negative 5 on both sides, now it's going to be a positive 3x. And, oh, okay, so negative 5, oh, okay. Negative 5 times negative 26. Again, sorry for the actual nasty numbers. This is just going to be a little bit nicer. 130 over 3. Does 130 over 3, does that make it into a nice number? 130, I don't think it does. No, it doesn't. No, it's going to be a fraction. It's going to be 43.33. Yeah, no, it's just going to be fine. It's okay. So we're going to have this number. Let's see if, no, wait, does 9 work? No, it's not going to be the same. Okay, sorry. Divide by 3 on both sides. You're going to have x is going to be greater than 130 divided by 9. And that's going to be for the right side. So let me just double check, making sure, because I'm getting kind of sleepy. Okay, this is why I don't recommend that you do math super late at night. Okay, let's do the right side. So if I were to subtract a 6 on both sides, this is going to be slightly different because we're going to have negative 6 and then a positive 8/3. So positive 8/3, that's going to be, what's that, negative 10, 10/3, negative 10/3 on this scenario. And then this is going to be negative 3/5 x. And then multiply both sides by negative 5 on both sides. This will be positive 3x, and again the sign switches directions, and we got negative 5 times negative 10/3. That's going to be a positive 50/3. That's going to be a nice number to actually deal with in this situation. And then we're going to be dividing by 3 on both sides. X will be less than or equal to 50 divided by 9. And no, that does not make a nice number, but it's okay. We are going to be trying our best to see what's happening. I'm going to say that this is, okay, so 50 over 9. I'm just going to say that this is 50 over 9. And then this is going to be 130 over 9. They're both closed circles. Now let's see. X is greater than 130 over 9. That's going to be increasing. That's going to go in this direction. And then less than, that's going to be going in this direction. So that's what we have for this scenario. Again, the main moral of the story is making sure that you get the absolute values by itself. You cannot split it up. Please do not split it up earlier. Do not distribute inside the absolute value. That is not allowed. You might be able to get away with it depending on what your outside number is, but I'm letting you know right now that it's technically not a legal operation that you're allowed to do in math. So, it's kind of a negative thing. So, don't multiply inside the absolute values. It will not always work. So most of the time, I guess you could say 50% of the time, 50% of the numbers will actually work. So that scenario. So. Please make sure that you get the absolute values by itself before you do the actual transformations, or not transformations, before you start doing the actual split up right here. Once you actually split it up to positive and negative. Let's see. We can do that. Okay, so this one, again, same scenario. You want to try to get x by itself. I kind of already started this problem. You want to get x on one side. In this case, I'm just going to add 3. Again, you can just see the actual operations. This is, I actually showed a little bit more work in this scenario. If you were there during tutoring today, I showed this actual problem to actually show you step by step of what's happening. But here you go. If you are watching it all the way to the very end, this is 2 hours and 29 minutes and 15 seconds. Okay, so let's see. Next one, hopefully, actually, I don't think I need to do the other problems. They're just getting x on one side. Hopefully, you understand that whenever you deal with the absolute value, or without absolute values, you do not split up whatsoever. There's no splitting of positive or negative. There's nothing on that sort for anything that you see on page 3 and page 4, which is going to be problems number A through H. So problems 2A through H will not have absolute values. You do not split up whatsoever. There's no splitting whatsoever. You only split up when you have an absolute value, and also more specifically when you get the absolute value by itself. So when you get the absolute value by itself, then that is when you can actually be able to split it up. Only when it's by itself. You're not able to split it up at the very beginning in this scenario. You cannot unless it's by itself. So for example, this problem right here, this is by itself, so you can split it up right away. Now let's see. Okay, so I did some problems. Oh, okay, so if you're actually really watching this video, you're welcome. I just did quite a bit of worksheets. You can literally just copy, but let's see if anyone is actually watching this long video. Let's see. Okay, so this is going to be the solution. There's two ways that you can actually do it, by using just, graphing the actual line and then making sure that it is a dotted line, because you do not see a line underneath. And then how do I know? There's two ways. Well, you can just assume that, well, what we did before, if it's y is less than, you shade downwards. Hopefully that's kind of clear of which one is going to be above and which one's below the line in this scenario. If you do not believe it, you can always just plug in the actual answer like this. 0, 0 is my favorite point. Plug in the actual points, 0, 0. See if it's true. If it's true, then you are good to go. You shade on that side. If it's not true, so for example, this side over here, I will show you the problem, so don't worry. So for example, in this problem over here, if I plugged in 0, 0, after I graphed it and did all the shading, look what happens. It turns into a false statement. So that means that this is going to be not true. Anything on this side over here, is not true. Everything on this side. And only above, the opposite side, will be true. If you don't believe me, you can always just plug in values and see if it's actually true or not true. Let me just zoom out so you could see the entire work. Again, just plug it in if you want to, just to double check your actual work, or you could just say that it is going to be true because it's going to be in the shaded region if you needed to verify any of the points. Same thing with over here. Again, you just need to verify. When you have when you have a system of linear inequalities, that was the next question after this situation. I can't show you because that was on Delta Math. It's going to be like this. You're going to see something similar to this on the actual retakes. Please make sure that you only shade in the solution. The solution is only going to be the overlapped region. You do not shade in the parts where it is not an overlap. So only the overlapped. So I know that you're shading above the red line, the red or dash line, and below the solid blue line below that, but the solution is only the overlapped. That is this section that I highlighted in purple or scribbled in purple. It's only the overlap. And you got two scenarios of actually proving that it is going to be part of a solution. If you're given a point, you can just plug it in. If both of them are going to be true for the inequalities, then it is a solution because they satisfy both inequalities. Which are the inequalities? Both of these up here. Now, if one of them, for example, if I were to plug in this point into this inequality, which is going to be the blue one, it is going to be true. That is this point over... Oh, I didn't prove it over here, so that's going to be... I guess I erased it. I guess I did. 1, 3, that's supposed to be right here. Oops, why is it not working? That is this point right here. Encircling right there. It is true for the blue, but look, it's not true for the red. And it also proves right here it is a false statement. -3 is not greater than -1.5. So that is going to be a false statement. So that's going to be for the system of linear inequalities, for graphing, I guess you could say, graphing system of linear inequalities. Make sure that you are very clear about if it's going to be dashed or a solid line. Just make it very clear. The arrows are not enough. If you just do the arrows, it is not enough. So if I were to just have the blue and red arrows, that is not enough. You need to shade. The solution is a shaded region. You got to be very careful. So this is your solution for this one, for inequalities. Again, it looks like I kind of giving you the actual answers, but if anyone's watching this entire video, then yeah, you can watch it. Let me just do a couple of these problems for the retake assignments. Okay, so let me do one that's a little bit more finicky. So I did these two of them that was kind of like these, so I don't want to go through that one, but let me go through a negative one and also a decimal right here. So same idea. You're going to have y is equal to a times b to the power of x. I'm not going to color code it. You can look at the previous to see what's going on. You're going to have 240 is equal to a times b to the power of negative 2. That's going to be for this equation. And then you're going to have 7.5 is equal to a times b to the power of 3. Now, since we have a negative exponent, I always tend to get rid of the negative exponent. I don't like negative exponents. It's actually preferred to not have a negative exponent. We always avoid negative exponents or change it to make it a positive exponent. So the opposite, or to do that actual operation, you're going to see that negative exponents, you're going to follow this rule. When you have any power, x to any power of that negative power, so for example, in this formula that you actually have, negative or x to the power of negative v, it's going to be 1 over x to the power of v. But let's say if you have a negative exponent at the bottom, say for example like this, then it goes up and just a positive v. So you're going to see either one. Most of the time in these type of problems, you're only going to see this scenario. You're not going to see this scenario unless you're doing something and out of order, at least not my recommendation. So always start with the negative exponent and just get a by itself with that part right there. So let's see, let's get a by itself. This is going to be a divided by b squared, and we got 240 right here. Again, we gotta get a by itself, b squared, both sides. Oops, that's a huge 2. I'm getting really tired. I want to go to bed, but I want to make sure I can do everything I can. I want everyone to do well. Please just try. I want you to do the best you can. This is what my a is, 240 b to the power of 2. I'm going to plug in this b value into the second equation. This is going to be 7.5 times, what is my a value? It is going to be 240 b to the second power times b to the third power. All I did was said, look at what a is equal to. A is equal to 240 b squared. Well, that's a, and that's the same as 240 b squared. So all I did was just replace a with 240 b squared. And again, we got an exponent rule. When you have the same base and you're multiplying them, you are going to be adding the exponents. So this is going to be this is going to be 240 b to the power of 5. This is 7.5. Let's see. 7.5. Divide. We're going to have to divide. Okay, I'm not that good. I'm going to have to get my calculator. 240 divided by 240 on both sides. I feel like it should be something's going on, but no, everything's right. Okay, I guess it's just going to be the way it is. Okay, so we're going to have, looks like we're going to have a decimal. So we're going to have b to the power of 5. And I'm not that good, so I'm going to have 7.5 divided by 240. If you put that into the calculator, you are going to get, okay, so you're going to get two answers. So you're going to either get 132, which I'm just going to leave it as a fraction, or if you put it as a decimal, it is going to be 0.03125 if you decide to do the decimal route. but I'm just going to leave it as a fraction just to make things a little bit easier, and also to show a non-sponsored ad from that calculator. So we're going to see b to the power of 5 is equal to 1 divided by 32, or do that square root symbol. It's going to be the radical symbol, I should say. And then we're going to have the fifth root, that 5. I can't write a 5 right now. It's moving. I got to do the fifth root on both sides. So b is going to be equal to, if I were to plug it into the calculator, that's not sponsored. Okay, so fifth root, and then look how nice and non-sponsored this ad is by Casio. So the fifth root of 1/3 is going to be 1/2. So you can do 1/2, or you could do 0.5. Either one, it is perfectly fine. I'm going to write down 1/2 because I tend to use these fractions for these type of problems. I tend to use the multiplier to have an actual fraction instead of a decimal, but it's up to you, or whatever that you prefer. So right here, you're going to have 1/2. So what is my b value? 1/2. So how do I find my a value? Plug it in. So this is going to be 240 times 1/2 squared is going to be equal to a. This is going to be, again, not sponsored. This should really be paying me. So 1/2. Look how, oops. Looking at the camera, not the actual calculator. So there's a bit of a lag when I'm pressing, and that's going to be squared, and then oops, press enter. That is going to be 60. So a is going to be 60. And there you go. So now we know what our equation is. This is going to be y is equal to 60 times 1/2 x. This is my equation. Hopefully that answers your question for this scenario. You're going to be doing the same process. I know you might be getting some weird numbers. You might be getting negative numbers or fractions. Again, my suggestion is always do the smaller exponent for b. Get that a by itself and plug it into the other equation. If you do it that way, you're not going to have an end result like this situation. You're not going to have a negative exponent, and you would have to do extra steps. Trust me. Just if you do it this way, you're going to get it perfect every single time. It's going to make your job a lot easier. So replace the x and the y for each of those points, and you should be fine to go. Again, it's okay if you get some weird answers. So this one, again, the setup is still the same. It's always going to be that y is equal to a times b to the power of x every single time. You're going to have 7/8 is equal to a times b to the power of -3. The same exact process. You are not changing the process. If you do the process that I'm showing you, your future teachers will be happy and get the answer correct. Again, you want to get that b to the bottom because you do not want a negative exponent. Okay, wait, hold on. Okay. Let me just show you. Let's see, it is late, but we got a visitor over here. If you see, you can type in second cats right over here. He's just looking around. He just wanted to see. He was scratching. He was kind of meowing. I'm not sure if it picked it up, but here he is. He's just kind of looking around. Cat cam. I guess he misses me. He wants attention. So, but let's get back to math. At 11:21. Again, you want to get the actual exponent by itself, or you want positive, not negative, and then you would get a right here. You're gonna have to multiply both sides by 3. or b to the power 3. This will be 7 ace b to the power 3. Plug it into this equation. Again, it's going to look a little bit different, but it's still the same process. If you follow this form, it's going to work every single time. Every single time. So you're going to have 7 ace b to the power 3, b to the power 4. This turns into b to the power 7. This is still 7 eighth. Multiply. I'm not going to do the rest of the problem, but hopefully you can see it. I will actually, let me just do it quickly, because that will give me less work and you get to see the actual process of what's actually happening. So 8 divided by 8 is going to be just still 1. You got 7 times b to the power of 7. Then you're going to have, what's 8 times 1? 12. 8 times 1, 12. That's going to be 8, 12, 96, 896. Now the, okay. Okay, sorry if anyone has cats. The cat just wanted to come inside, mess around, and then wanted to get out. So cat things, just doing cat things. So now I just gotta wait for them to run around at 3 a.m. because they like to go for runs around 3 a.m. in the morning and wake you up. Okay, now we gotta divide by 7 on both sides. We're gonna have b to the power 7. I'm not that good on that, so let me use a calculator for this. So we got 896 divided by 7. This should be a nice number. Yes, it is. We got 128. How do I get that b by itself? Well, I need to do the 7th root. Again, you have to match up with whatever the exponent is with your number. So that's going to be the 7th root. So the 7th root is going to be, again, not sponsored. Let's go into the sponsor can, sponsored by Casio. We have the 7th root of 128. Okay, let's see. This is going to be 2. So, again, it's very nice to actually have that calculator. Cannot recommend it. Hopefully, parents, please do that calculator. We got 7 eighths times b, which is 2 to the 3rd power. We actually do not need the calculator for this one. What is 2 to the 3rd power? 2 to the 3rd power right here is 8. Now, if I were to do 7 eighths divided by 8. Well, what is 8 divided by 8? Just 1. This gives me 7 to be a. So that means my equation. Did I say question or equation? I don't know. I'm tired. Okay, so this is going to be y is equal to 7 times 2 to the power of x. So hopefully this is going to be a good enough review. Just make sure that you follow the steps. Especially, I would recommend that you want to rewind for version A, because I was speaking a little bit more a little bit correctly, I guess you could say that. Coherently, I guess, if you want to say. Yeah, okay, so this is the graphing. I already showed you this. Did I do this? Oh, no, I didn't do. Hopefully everyone kind of did this. This is like the easiest one. This is going to be y is equal to 65,000. That's your starting value. And then you got to go by. Okay, well, it says growth rate at 8%. So that means you got to grow 8% every single year. So 8% above 100%, that's going to be 108%. How do I write down as a decimal? 1.08x. So you're going to be doing the same thing. It's either going to be adding or subtracting. Some along those lines, you're going to be doing something along those lines. Now that is for that one. I already did that one. Let's see. Okay, this one. So every single time you're always going to be doing something similar. It's either going to be a pond, some type of pool. Every single time it's going to be either filling up or emptying the pool by a certain rate. Just make sure that you round to the nearest tenth, like what it says in the problem. Make sure that you, sorry, I burped. Make sure you do your curve. So it's either going to have two curves. This curve, like something like this, or like this. Something along the lines. It's either going to have a blue curve going, blue curve going downwards, like kind of like that curve, or a red curve going upwards really fast. So it's going to be one of those two where it's going to be. Just make sure that you emphasize the shape of the actual curve and also get the percentage, and also make sure that you round to the correct one. This one I'll just give you the equation for. Let me just see because I'm already here. Okay, so I'm starting at 100 gallons, so that's going to be y is equal to 100. I'm growing, okay, fills the pond at a rate of 26% each day. So they're filling up the actual pond, 26% of it every single day. So they're increasing that pond real quick. So this is going to be 1.26%, which is, 126%, which is going to be 1.2 for the, or 1.26 for the multiplier, which is letter B. And then you are not putting a 0, you're putting an X. I'm not sure why I put a 0. So you're going to be putting an X right there. This is your equation for this problem. You're just going to be plugging in these values. So one at a time, plug it in. And then for this one down here, you're just going to be doing this equation 100 times 1.26 to the power of 28, and then plug it in, and then you just need to make sure round to the nearest tenth. Now some of these answers are going to be kind of weird. They're going to be 0 0 0, say 3 6, and I said round to the nearest tenth, so that means this number. Sometimes some of these answers, they're going to be so small, they're just going to be 0. So 0 gallons or 0 money or something along those lines. It could happen. I'm just letting you know that that can happen. And all I'm saying is round to the nearest tenth. If it's 0, then it's 0. That's rounding to the nearest tenth. You know, that's perfectly legitimate. So that's for the pond situation. Another common one is, let's see, this is still pond. Oh, here's go. Investments, savings accounts, or the great investment opportunity, something along those lines. You are going to be seeing something like this on the retake. This is a classic example when you have a savings account or investment and it's expected to grow in value. When you say grow in value, you're thinking of increasing its value. So that means you're going to be gaining money. So if you say 13% for increase, and that should be obvious that it's going up. So that's going to be the factor, or the multiplier is going to be 1.13 for the multiplier. And what am I starting with? 900. There's your equation right there. Y equals 900 times 1.13 to the power of x. And yeah, just make sure that you plug it in. And again, key word is just decrease. So that means you're losing. What's your multiplier in this rate? This is going to be 0.75. That's going to be your multiplier for this scenario, for this problem, because you're going down. Let's see. I already talked about the curve. Okay, see, summer. Here's a common one as well. You have money at the start of the semester. Say that you did very well. Say, for example, in your favorite math teacher's class at Eastlake Middle School for IM1. I'm just saying that could be true for some people. But say that you got a lot of money. Say that you did very well. You did a good job. You did well in the final. You got a good grade. And you got, say, $3,400 for doing well at school. So that was your promotion gift, if you will. You'd say that you got, your grandparents gave you money, boom, you got that money. But you are spending 35% of your money every single week. So 35% is being used every single week. So you're slowly going down very quickly. 35% of your money every week, that's going to be going down very fast. So when you say spend, that means you're losing. So that's going to be decreasing. If you gain, another keyword, gain, that's going up. So that's pretty much all I have to do and explain this situation. Let me see if I need to think of something else that I need to talk about. Common mistakes. Yeah, that's pretty much it. If you can just review this, that'll be good. Let me see if I can get my other cat. Might as well, since I got two of them to be on cat cam, if you will. The orange one at the beginning, and then we got the Persian. And then let me see if I can get the tuxedo one. Okay, it looks like I can't get the cats. At least the orange one is actually crying a little bit because it wants attention, but hopefully that's it. Hopefully you did follow along. This is kind of a long video, but hopefully I gave enough explanation. Let's see. I'm trying to think of what else I can really say. There's not much that I can say. Pretty much went over the entire chapter 9 test, explained everything I can. Shading, just I suggest that you review these videos if you want to make a highlight. I'm not editing or annotating. I'm not Mr. Beast or Phase Rug or whatever YouTubers that you guys watch. I'm not annotating anything. I'm just going to leave it. If you want to make some key points of what you want to focus on, you can just make a note on your phone and then just review right before the actual test. And then boom, there you go. You can just do the best as you can. So you can do the retakes as, as many 100% as you will. So if you with that being said, hopefully you enjoyed the video. It's gonna be a long one and I need to go to bed. So that's it. Bye.